Today, since we're studying chemical reactions, you're going to learn what a chemical equation is. Okay, first a definition. What is a chemical equation? A chemical equation is a very detailed description of how matter undergoes a change. Question writer?
Are we putting this on table of contents?
Oh yeah, probably put that in your table of contents too.
Okay.
Chemical equations is a very detailed description of how matter undergoes a change. That's all.
Is that theory?
Yeah. Still. Okay. So here is an example of it. And we're actually going to learn all kinds of details that this gives us. So here is a chemical equation. We have H2, which then in little parentheses, I'm going to put this little G here, okay, plus O2, which is oxygen gas, and yields a product, H2O, and it's a little L like that. So all of these little details you need to include in your chemical equation, okay? This chemical equation describes how hydrogen gas and oxygen gas combine to make liquid water, which is H2O. Okay? And if you'll notice, there's something going on here too, that if I had two hydrogens and two oxygens atoms, would it make a water molecule? Is that possible? To have two of these and two of these make one of these. Is that even possible? Would that even happen? Could you? I mean, something seems really wrong there. And that is that, yes, Seth?
There's only supposed to be one oxygen molecule?
Yeah, but oxygen doesn't exist as only one. It exists as two. Remember, it's one of the diatomic ones. So this equation, you'll notice if you do the math, if you count atoms, and this is what you will be expected to do, is count atoms, not necessarily have to balance it yourself, but if you have four, there are 4 atoms over here, aren't there? And there are only 3 atoms over here. So where did the other atom go? Yes, Henry?
If it was a chemical reaction, could the atom been destroyed? Is that how it works?
So one of the biggest concepts in chemistry is that matter cannot be created or destroyed. You'll never lose matter. You've got to always have the same amount of matter over here as you started off with. So there is another way we can account for it though, and that's called balancing the equation, okay? You guys aren't going to be expected to balance. I'm not going to give you homework where you have to balance equations. In high school, you will be expected to balance equations, but in middle school, my expectation for you will be to spot if there is balance. And you can obviously tell there is not balance in this equation, right? But if you put a 2 here and a 2 here, using coefficients, okay, we can balance the equation. Now we have 4 hydrogen atoms, and over here we have 4 hydrogen atoms again, because 2 water molecules will have 4 hydrogen atoms, right? So we balance using coefficients. And again, you will not be expected to balance them yourselves. You'll just have to be able to spot if they're balanced. Remember that sheet we did with subscripts and coefficients? Yes. Okay, it would be incorrect to do this, to make balance, to go like this. You can't go like that. Because if you do that, this is now H2O2. It's a completely different chemical. It's not H2O. H2O2 is hydrogen peroxide. And this is not the reaction to make hydrogen peroxide. Okay? So, parts of a chemical equation. Over here on the right-hand side, you have what are called the reactants. Okay, so these are all reactants. Everybody that's on this side is considered a reactant. Over here, everything that is made is called a product. Reactants form products. So the arrow, and how we actually say that when you're reading a chemical equation to someone, just like you would read a math equation like 2x plus 3y equals 18 or something. This, we would read it 2 hydrogen atoms plus an oxygen molecule. And the way we say this arrow is we say yields. So the arrow means produces or yields water. Hydrogen gas plus oxygen gas yields water. So what are the little g's here in the parentheses for? They tell us very specifically, very detailed, they're telling us specifically the exact state of matter that our reactants or products are in. So if it's a G, here's your little options. If it's a G, that means that they are gases, or that substance is a gas. If over here you see the little lowercase l, that means it is a liquid. Okay? What would be some of our other possibilities?
Solid.
Solid, so S probably. So if S parentheses, that means the product or the reactant is a solid. It's in solid form. And there's one more that you need to know about for this. Sienna? We wish it was, but unfortunately it's not, because we can't deal with plasmas. Humans would, if you were carrying out a chemical reaction with plasmas, it's probably in a big super collider. But the other one is very quite common in the laboratory, and that is AQ. If you see an AQ next to something, that means aqueous, or which basically means it's dissolved in water. And dissolved is spelled this way, not that way. Dissolved in water. Okay, so a lot of times our solids, we'll take solids or liquids and we'll dissolve them in water before we react them. You'll see also with vinegar and baking soda, if we just took acetic acid, pure acetic acid, that was pure powder, and pure baking soda, and mixed them together, mixed the two powders together, there'd be no reaction whatsoever. They just won't react. But if we put water on them, then they will begin reacting. So some things have to be dissolved in water in order to react with the things they're going to react with. Okay? So here are some of the most basics of a chemical equation and all the specifics here too. Okay?